Hello! Today I'm looking at the Fnirsi spot welding machine SWM-10. Let's unbox, and that's the machine, and under here we have the probes, a little bit of I think it's 10mm nickel plated steel strip and a charging cable. There's also this manual in several languages, and you also get a spare pair of screw-in copper alloy tips. So this is a self-contained spot welding machine with the power source included. It's I think 2 cells lithium ion, although I believe they're in parallel because you've got voltage on the screen and it comes up as 4 volts. On the back there's a stand, so you can stand it up. It's actually a very convenient form factor. You can stand it up, and then the probe connections are up here, so you plug them in and do your welds in front of the machine, and you can see what's going on the display. Let's turn this machine on. There's a power switch up here. Actually, I'll go through these. That's the Type C charge input. That's the Type A power bank output. You can use this as a power bank. And there's a reset hole there. So press and hold the power switch and this comes on very quickly. There are 2 displays. This one is the spot welding display. Press the power button briefly, and this is the charge and discharge display, power bank mode you could call it. Let's peel off the display protector and we'll have a look at the elements on the spot welding display. Okay, this green dot means ready to spot weld. That's the voltage of the lithium ion cell, 4.05 volts. Temperature inside the machine, that will creep up as you're spot welding. The beeper volume, although I have, it does appear to be a very quiet beeper. This is the battery state of charge indicator. Okay, so the main spot welding elements are the preheat pulse length. So that warms up the 2 pieces of metal prior to welding. The interval, which for some reason is 3rd on the list, that's the gap between the preheat pulse and the actual welding pulse. There is the actual welding pulse, and dots means the number of welds. So it will simply do this double pulse weld this number of times, and you can have 1, 2, 3, 4 or 5. This actually shows you the current of the last welding pulse you did. This is the number of welding pulses you've done in this session. This resets when you power the machine off. And here you've got warnings, short circuit, over temperature protection, and under voltage. If the battery voltage gets too low, it will stop you using the machine. Let's switch to the power bank screen, and I've now connected a charger to the USB Type C input, and you can see we've got voltage of the incoming charging voltage, the current, so it's nearly 2 amps, and the power 9.2 watts. And actually, if you switch over to the welding screen, you actually get to see the voltage of the internal lithium ion cell, so that's also quite useful. And then if I go from charging to discharging, I'll show you that screen. I've plugged in a little LED light here, and you can see that the output voltage is being boosted up to 5 volts, so it's a USB output. There's only 120 or so milliamps and 0.7 watts going out to that device. Now, although you may think, well, using this as a power bank is not going to happen very often, what I suggest is that it could be quite useful to take the voltage of the internal cell, so if I go back to the spot welding screen, to take this voltage down to a storage voltage, because you're going to want to look after the lithium ion cell that's in this unit. So after you've had a session of spot welding, you might want to take that down to 3.8 or 3.7 volts. Right, let's do some spot welding. What I would suggest is turn this off, because you don't want these sockets to be live when you're connecting the 2 spot welding probes. So let's plug those into the 2 sockets. They're quite close together actually, and these 2 black plastic things do interfere with each other just a small amount. Okay, let's take off the probe covers at the other end, split the probes up, put the thing on its stand like so. I'll move my torch in a minute, and let's do some spot welding. So switch on, press and hold to switch on the spot welder. Now the manual recommends you start with a preheat of 2 milliseconds, so I'll do that. So we're on that parameter. I can go down to 2 milliseconds. I'll do a 4 millisecond gap, and well, let's do a 5 millisecond pulse and see what happens. So this is one of these spot welders where when it detects a short across the probes, it then puts a pulse out. Right, this is pure nickel, Ni. Oh, that's rubbed off a bit, but this is the pure nickel strip, and I'm going to spot weld it down to this quite heavy duty galvanized steel bracket. It's probably about 2 millimeters thick. Now, I have never spot welded pure nickel strip before, so this is my first ever weld, so let's give it a try. I am wearing glasses, incidentally, mainly so that I can see what I'm doing, but I think it's also important because you do get some sparking. Okay, let's try my first weld. And there was no sparking there, but you did hear a click, or I heard a click, and so that has oh no, that hasn't welded. Okay, I'll have to do a bit, raise these settings a bit. Actually, what I might do is move to the dots field. So this is the number of times it does this weld with these parameters. And I'll take that up to 2 dots and we'll try again. So we should hear a double pulse. Let's try that now. I ought to tape this down really, but let's give it a go. Ah, it says short. That's interesting. I wonder why it said that. Okay, well, switching then to the nickel-plated steel strip, because I've got a bit more experience with that. Let's see if I can do a weld on that. And that's also come up short. Yeah, I haven't had that before. And also, there's no current value there. The current is reading as 0 amps, and yet that has actually welded. Oh, not very well. Okay, it did do a weld, but it's not a very good weld. Okay, I'll have to play with these parameters a bit. Okay, that's interesting. It didn't seem to like this very heavy duty galvanized steel bracket. Perhaps the resistance of this is just so low it flags it up as a short. So I've just done a weld on this knife blade, which is thinner. And yeah, that is a successful weld. That appears to be quite strong. So let's try that again, and I'll do it on camera. Make sure this is all in view. So this is nickel-plated steel. And I felt a double click. I don't know whether you heard it, but and you can feel a little bit of warmth. It's just very mild bit of warmth there. But yeah, that's done a successful spot weld between the strip and this steel blade. Now I suppose this is not very representative of lithium cell, so perhaps that's not the best thing to be welding onto. I think what I'll do, I made this jig for welding when I was testing my supercapacitor spot welder. Let's try doing a weld on there. I'll do the nickel plated steel and see if we can weld that on there. I'm not going to change the settings. We'll just give this a go. Now I'm welding onto a curved surface, so I've got to be careful to hold the probes steady. Okay, that did a double pulse. Now we do have a current reading. Don't know whether you can see that. It's 644 amps, and yeah, that appears to be a successful weld. So my steel blade and my lithium cell are spot welded together. Okay, let's try the pure nickel strip again onto the steel knife blade, because it seems that I'm not going to be able to spot weld onto that big thick bracket. So pure nickel strip, my first weld, double pulse, and yeah, that is a successful spot weld. Another look at the display. You can see the temperature has risen up to 21 degrees C. I'm not sure where it's measuring that on the PCB, probably somewhere, I would imagine. You can see that I've done 7 spot welds this session. Like I say, that resets if you turn it off. The indicator for short circuit appears to work, so that's quite impressive, and current is showing as 600 and something amps. Okay, let's carry on welding. Now I did think that using this dots thing, say you set it to 5 welds, that you could actually move it between all the welds, but they're quite fast. They're probably about half a second apart, so I don't think the intention is that you move the probes and get 5 welds. It's simply 5 welds in the same spot, but you can set that to 1, 2, 3, 4 or 5, so it just reinforces the weld. Okay, let's do another weld. Let's see what happens actually if I put it on the dots field and take that down to just 1 dot. So let's try a weld up here by my number writing. So that's just 1 weld, and yeah, that appears to be a successful weld. I can't pull that off. Right, let's go back to my nickel plated steel strip and just do lots and lots of welds all across this steel blade. But first I have to take it off here. Now the question is, how easy is it going to be able to pull that off? Okay, so I have pulled that off, but it has actually ripped holes in this. Let's have a look. So there's the steel strip with the 2 holes that got torn through the strip when I pulled it off the cell. And I'll just bring in the cell, and you can see the 2 little pips there. They're quite extended. So yeah, that is a good weld, and I had to actually rip it to get it to come away. Right, let's do lots of spot welds. I'm on, it says sum 8. So I've done 8 welds, and I'm looking at battery voltage 4.05 and temperature 21 degrees. So let's just do lots of welds. 1, 2, 3, 4. Interestingly, there's very little sparking. Now, I seem to remember I had more sparking when I was using the supercapacitor spot welder, and it just occurs to me, I wonder whether it's to do with voltage, because this is running at 4 volts and the supercaps were running at 5, or slightly more actually. You could take it up to 5.4. I don't know, it's just a thought, but let's keep doing welds. Oh, that one made quite an indent. Let's have a look at that one, a close up. Okay, I've worked out why. It's because there's a hole in the knife blade, so that explains that. Okay, let's keep doing welding. I'm up to 17 welds. Let's just keep doing these welds, because I'm kind of interested in how the battery voltage is falling down. It's now 4.0. Well, it's on the verge between 4.04 and 4.05, and we're up to 22 degrees Celsius internal system temperature. I'm running out of space to put welds actually. Okay, there we are. 4.04, actually 4.03 I saw come up there briefly. 22 degrees Celsius. It doesn't seem to get overly hot inside the unit. The last current was 626 amps. Does that actually change on each weld? 628 amps, so yes, I guess it does. So what's the quality of these welds? Well, the only way I can really show you is by trying to pull this off. So I'm going to just wind it round. Yeah, they're quite solid. I mean, I am peeling it off, but you can see there's a lot of detritus left on the knife blade. I would say those welds are certainly solid enough to pass a decent current. Let's have a close-up look at that. So those are my torn welds. Let's take a look at that side on. Yeah, I mean, you can see they're all torn from the steel strip. So those are good welds. Yeah, I'm struggling to find things to say about this, and I can only think that it's because it's really simple to use. You just plug these probes in, flip the stand like so, switch the thing on by pressing and holding, a bit longer than that it would seem, and it's ready to go. I mean, it's incredibly easy to use, and the spot welds are pretty good. There are 3 LEDs down the left hand side of the display. The blue one comes on when you're drawing power from the unit. It's not terribly bright. The green LED comes on here when you're charging the unit, and I presume it stops flashing when the battery is fully charged to 4.2 volts. You can't see the battery voltage when you're charging. You have to switch over to the welding screen, and then we can see it there, 4.09 volts. Now there is also a yellow LED here in the middle, and apparently it comes on when your two probes touch the work while you're welding, but I've never seen it because you're not really watching the screen. You're really keeping an eye on where you're holding the probes. So I'm not sure that that yellow light is terribly useful, but yeah, it is there. So I've come to the AliExpress listing page for this spot welding machine because there's some quite nice photographs here. It explains double pulse welding technology, one-touch welding, so you just touch the probes and it does the welding pulse. So nickel plate up to 0.25 millimeters thick, sheet iron and steel sheet. It also mentions stainless steel sheet on here and in the manual, all up to 0.25 millimeters. You've got the probes. They appear to have changed slightly because the probes I've got are screw-in probes, so they've obviously changed that slightly. Now here's an image of the two lithium-ion cells. They're flat pouch cells, and you can see they've got these large tabs on them. So it's a 5,000 milliamp hour or 5 amp hour battery, so these are probably 2.5 amp hours each. Maximum current 1200 amps, although I've never seen that. I've only seen 600 and something amps. And you've got this spot welding machine, and it also doubles as a power bank. Intelligent temperature control. Also, it has that short circuit detection, so it didn't like my really thick galvanized steel bracket. 1.8 inch TFT display, and some stats here. Now it does say here welding materials: nickel sheet, iron sheet, stainless steel sheet, and aluminium sheet. Aluminium sheet I'm not sure about because that's got a much lower resistivity. I'm sure that would trigger the short circuit detector, but certainly nickel plated steel and stainless steel, I would imagine, are doable. And here's the contents of the package. Now, a little bit on looking after the batteries in this unit. I have an electric car with NMC cells, nickel manganese cobalt, and you really do want to look after NMC cells, so don't leave them at particularly high voltage for long periods of time. So what I would suggest you do is use this in power bank mode. So I'm going to charge this other power bank and actually discharge this thing down, so you can see that it's pulling 5 volts. Oh, 1.7 amps, that's pretty good. So we're down to 3.99 volts. So probably if I wasn't using this for a long time, I'd discharge the internal cell down to something like 3.8 volts. Just not leave it at a high voltage for a long period of time, because the cells in here look like they're specific to this unit. They do have those very wide tabs. It might be tricky finding replacements for them. So while I'm discharging this, I can see the voltage on the welding screen. If I switch over to the power bank screen, I can see that it's putting out on the USB type A connector 5.2 volts, slightly disagrees with that. 1.7 amps, yeah, similar to that, and 8.8 watts. It says charging even though it's actually discharging. So what are my impressions of the SWM-10? Well, it's a very convenient package, easy to use. Just flip out the stand, plug the probes in, and pretty much you're ready to go. It's producing excellent welds both on nickel plated steel and pure nickel strip. It's got these protections, so under voltage lockout if the internal cell gets a bit low, short circuit protection, which we've seen on this very thick galvanized steel bracket, which it won't spot weld onto, and for good reason probably, and over temperature protection as well. It's also got this power bank mode, which may or may not be useful to you, but certainly I think it's useful to get the cell down to a storage voltage if you're not planning to use this device for a long period of time. And of course, it's very easy to monitor the cell voltage when you charge this up in preparation for doing some spot welding. Now, I was wondering how easy it would be to get inside this unit if perhaps you were having to replace the lithium-ion batteries. And I did notice that these feet actually slide out, little pieces of rubber that slide into these recesses, but there's no screw behind there. This strip appears to be stuck on with adhesive tape. It's quite possible that there are a couple of screws underneath there, but I don't think I'm going to go to the extent of peeling that off. So an extraordinarily neat, easy to use, competent spot welding machine. I don't think there's much more I can say about it. You will see me using this in subsequent videos because I'm going to be making up battery packs. Big thanks to Fnirsi for sending me this SWM-10, and in the description below this video there will be purchase links and coupon codes if there are any. But that's it for this video, so cheerio.